be familiar with me, but for a little bit of background, I got a master's degree in artificial intelligence before people even did any of this type of stuff, a very long time ago. My specialty back then was in natural language processing, rule-based systems. Over the years, I've worked on a lot of things, but sort of not the most modern way of doing it, the more traditional way. So I've done a lot of work on imaging. I've done a lot of work, with data ontologies. I've worked on autonomous vehicles and things like that. But in the last couple of years, everything kind of changed, so I had to reinvent myself. So not only am I full of all this massive amount of what's rapidly becoming useless knowledge, I'm going to learn the new ways of doing it. Okay, so that's kind of my background. All right. I also, if I didn't mention, I worked as a principal research scientist for Sharp Corporation of Japan for about 20 years and have about 115 U.S. patents based on my research. A lot of it's in the area of imaging. So what I'm going to talk to you today is I'm helping steer and oversee a new open source framework that's being launched here. If you're familiar with machine learning frameworks, there seems to be a new one every month. Okay, but I've kind of noticed they seem to have a gap, and that's what I'm going to talk about. So let's move forward. So lots of frameworks, but they're all focused on the model and training the model, and that's the cool part. Okay, what's really kind of overlooked in them is that still today, people tell me the majority of the development work when you're doing natural language processing or computer vision is still getting the data ready for training. Okay, and numbers I hear, it's not as bad in computer vision, but I'll hear between 60 to 80% of the work is on the data and not on the model, and it's worse in the natural language processing, 80 to 90%. And kind of one of the reasons is that these systems are great for learning things. So if I give you the model noise, guess what it's going to learn? It's going to learn noise. Okay. So that seems like a gap, that none of the integrated frameworks address the data engineering side of it. There's lots of little components out there for machine learning engineers. That's what an MLE is now. That you use, things like NumPy, Pandas, Scikit-learn, the Natural Language Toolkit, just tons of them. The problem is that if you take online courses, whether it's Udacity, Udemy, or go to blogs by well-known people, or even the big companies that put out frameworks and have tutorials, if you look at their code, the code for the model tends to be fairly short, and everything it takes to get up to that point can be hundreds, sometimes 1,000 lines. Okay, it's generally written sequentially. That's not how programmers write. Okay, there's little design, poor reuse, and I never see any object-oriented programming in any of that. Okay. And so that's the gap. So this framework is to address that gap. Instead of being focused on the model, it's focused on the data engineering. The approach here is not to reinvent everything, but to actually build a bundle that takes the good open source components, bundle them together, create an abstraction, which you would know as an API or an SDK that supports OOP programming. So that's your rank and file software programmer, be familiar with it. And then tailor that abstraction to support design patterns that are familiar to software development engineers.
So is that essentially a facade on the other tools?
What do you mean?
Is that essentially a facade pattern on the other tools?
Yeah. Well, you got bundle and abstraction, glue code. Okay. I mean, there's a lot of people who are doing machine learning. There's a lot of good nuts and bolts out there. But the reason they're writing hundreds or thousands of lines is they're trying to figure out how to put these nuts and bolts together, right? Everybody has a different way of doing it. It's just one big mishmash spaghetti. Okay. So important design elements that are being considered in this framework is one is abstraction, having templates, data binding, an object relational model supporting CRUD and being asynchronous. These are all the kind of design patterns every software web developer today is familiar with. So those are, objectives of the new framework. Okay, so I'm going to do a little bit of a code along, so let me break out of this. Before I do that, does anybody have any questions? Okay. All right, so I'm going to start with some basic stuff. I don't expect anybody to install anything. This is actually just sort of a dry run about how to start presenting this. There are several modules. The first module is what we're going to talk about is getting text data outside of primarily PDF documents. Okay, but other types of documents too, fax documents, which would be TIFF, or image capture documents. You take in your camera and you took a picture of a document. There are some really good heavy lifting open source tools out there to work with. One of them is Artifact's GhostScript. It's been around a long time. It'll do anything you ever want to a PDF. Okay. Image Magic's Magic is basically an image manipulating library. It too has been out there a really long time, open source. Google's Tesseract is really best class right now at OCR. I'm currently using their 3.1 version, which is a restored version, but they're now coming out with a 4.0 one that's based on a neural network and LSTM. So it's going to be able to handle things like orientation and skew in your document as well. Okay. So, and then the natural language toolkit. So those 4 components we're using in this particular module, but I'm going to go introduce you to some of these open source packages by hand. Okay. So I'll skip over the install. So that's how you would install GhostScript, how you install Magic, Tesseract, and the NLT toolkit. Okay. So let me just start here. I'm going to run that. Okay. So first thing I'm going to do is I'm going to just show you a quick by hand how to extract text from a text-based PDF if you were using GhostScript. You'll find lots of blogs on this type of stuff. GhostScript is been around at least 15 years, and its command line arguments are very cryptic because of where it's rooted from. It doesn't have today's modern style. When I want to do something with GhostScript I've never done before, I just Google and find the answer in StackOverflow. Don't bother to try to read a giant, thick manual on all of its options. It's just useless. Find somebody else who already figured it out. Okay, so one of the things I wanted to do with PDF documents, or what we find people want to do, is they want to be able to classify not only what the document's about, but what everything on every page. So, for example, if it's a medical plan, you want to know, is the document a medical plan? And then look at the individual pages. Is that a table of contents? Is that the legalese? Is that what's covered? Is that what's not covered? Oh, is that the foreign language translation notices and stuff like that? So it's important to be able to split these documents up. So the first step here is just a GhostScript step that goes through. It tells me how many pages are in that document. So in this case, where was the document? This turns out to be a medical plan. Okay, I think it's for the Air Force. Okay. Yeah, all the government agencies, all that stuff is out there in the public, easy to get to. Okay. But what I really want to do here is I'm going to go ahead, it might be easier to stand, tell it to split off to page 1. Okay, so if I wanted all 40 pages, I could just do this in a for loop from 1 through 140. Okay, but I just broke off page 1, and I'm going to go ahead and show it to you. So let me get to the right location. There we go. Okay, so it's a foreign service benefit plan, so that's really the cover page of that medical document. But you can see, if you were doing some processing, restoring each page separately, you could probably create thumbnails if you needed to have a viewer, so you could look at different pages. If you were doing classification, you typed in something like legal notice, it would know what actual page that is and display that on the screen. So that's one way of using just that type of simple capability. And again, this doesn't require a bundle or anything. This is existing other open sources, but we bundle them to make them more useful. So let me move on. Okay, another thing that's important to know is not every PDF is really text. I think everybody has gone to a PDF, tried to highlight some text to go copy paste. It won't do it, right? Because it's a scanned image that's been put a PDF wrapper around that. So this is a little tool here that will, well, first, getting ahead of myself, inside PDFs they have this annotation. It's called the PDF or directed PDF resource. And depending on those values, it will tell you what's in that PDF. So /text means there's actual text in it. These other ones mean they're images. So you can use that information ahead of time, poke into the PDF, to know ahead of time, is that a digital text PDF or a scanned PDF, and take it on a different route. Okay.
And
So
are those parallel? In other words, like some documents have both.
yes,
so
so
text and their phone static images.
right.
So would it be running both of those? Just kind of look to see if there's text.
Well, I'll when I get into the bundle, the framework, I'll show you how that works. But you certainly can go both routes. But again, right now I'm doing things by hand. So within the framework, there is this thing called PDF resource. These are all class objects. So once we start getting into the Epipog framework, everything is going to be OOP style. Okay, and I got debug on. And it's telling me in that one page we looked at, it's a combination of text and images. And if it's still up, I think I closed it. Let's open it up again. You know, these are images here. Okay, and the rest is text. And that's what it's telling me. Okay. All right. So, keep moving on. All right, and so that object, that resource object, has properties. One's called text. So if you're doing this in a software program, Python program, you just check these properties. In this case, they're both true. Okay, so because we know it's text, primary text, we can go ahead and extract the text data out using GhostScript. So move here. Again, it's cryptic. Last time what we did is we said the output file was a PDF. Now we're going to say it's a text file. And we said the device was a PDF write. So that means make a PDF. In this case, I'm telling it to generate a text file as the output. So we'll do that and then look at that. Okay, did I do that? There we go. So let's go ahead. So that's the companion file there. Oops, that's something else. There we go. And notice how GhostScript has a, to the best it can, maintain the spatial relationship instead of just crunching it all together. Okay. And one of the advantages of that is you can then have another process that comes through, looks at the spacing, and spots the segmentation that we do visually as humans. What's a title, what's a paragraph, and so forth. You know, because they're really, when you extract text out of arbitrary documents, especially a PDF, the system doesn't know that stuff. We know it from our ability to visually look at the document. Okay. There's that. So let's move on. So what was I doing here? Okay. Yeah, this is just kind of just, I already showed you the folder, so that was the original plan here. And here's where we split off page 1. Okay, so let's try another PDF, but we're going to have an unexpected result on it. And then I'm going to show you how we're going to get around it. Okay, this is another benefit plan. Okay, but if we did a PDF res on it, okay, it would tell us that there's text in there. And so I am going to run this. Okay, so the first time I'm going to split off page 1. And then I'm going to, from that page 1, right over here, I am going to split off, I'm going to extract the text from it. So let's now go view that document. I should be able to do it here in Notepad. There we go. Something went wrong. Okay. Directives and PDFs don't have to be correct. They're hints. Okay, so this PDF said this is a text file. It wasn't. It's a scan. Okay, so another important thing in the framework is to be able to identify these types of patterns and know, oh, that directive lied to me. I got to reroute this document through OCR. Okay, so we're past that. So we'll go ahead and extract text from a scanned PDF. So I'm going to introduce you to Tesseract. Okay. Okay, so the first thing here, GoScript is great. So I can tell GoScript to say, take a PDF, extract a page out as a PDF, extract a page out as a text if it's possible. But I can also tell it to extract a page out as a rendered image. Okay, and it'll support a lot of different types, JPEGs, PNGs, and that. Tesseract works best on PNGs. That's why I'm telling it PNG. I want to minimize the amount of processing time, for text. Who cares about color? So that's why I have grayscale PNG. Okay, so I'm going to do a lot less processing time and still have high resolution. That's another important thing to know. When you OCR, the resolution is going to highly affect the quality of your OCR, but the higher the resolution you're rendering, the more processing power. So 300 dpi is usually one where you can almost always reliably get accurate OCR on. And again, by making sure I'm only generating a grayscale PNG, I've kind of balanced the two off to optimize how long it would take. So let's go ahead and do that with Tesseract. For those not familiar with Tesseract, that is Google's open source OCR. Okay, and at the top of this notebook, which I can give you all a link to, you can find where to download it. So we took that PNG and we made, okay, so let's have a look where that would be. Okay, so that was, so here's the original plan. So this is that big plan. And we don't really need that. Okay. Then we pulled out the first page. Okay. Then we converted that first page to a PNG. Okay. And then we ran Tesseract on it to get the text. Okay, so that's how that process works. Okay, so now we're going to move into the framework where we show all this sort of automated. Okay, kind of the part you guys are sort of waiting for here, so let me get to the right point. I've gotten yeah, I got ahead of myself there, but that's okay. All right, so if you're not familiar with Python, here I'm just saying is I got this module. It's like a package. If you're in Java, that would be a package. If you're in C#, that would be a library. Okay, but here the module is document, and from them I'm importing the class objects document and page. So document represents documents. The page ob class represents pages within a document. Okay. So some of the arguments taken to the document object are the path to the document, the directory where you want to, so it's going to extract things out, extract pages, extract images, extract tests, eventually even do all kinds of NLP pre-processing, and you want to store that information somewhere. So that's where you're storing it. If you're doing thousands, especially if you're doing real time, and you got just a mass amount of documents come in, you do not want to do that sequentially. You want to do that asynchronously. So this has, it will process documents asynchronously, and you can set up your event handler per document when it's done to do some kind of post action. Okay, and then like a lot of frameworks, there's ability to inject some kind of configuration information of how to sort of wire your framework for a pipeline. So let's go back and let's play with that this North Carolina benefit document. Okay, so it's not the fastest laptop, so we may have to wait for a minute. But right now it's processing every page. There's 105 pages on it. But while it's doing that, anybody got any question?
So then, I'm not trying to jump ahead of where
No.
we're going, but presumably we're going to assemble these individual pages back into a document? Would that,
You can do anything you want, but we'll get to that.
so then the other aspect I wonder, you were using GoScript before and you ended up with garbage, but it mispresumed that it was dealing with text
Right.
and was not. Does that also, do you also run into issues? I've seen a lot of dirty PDFs where they have OCR run, but it's run terribly, and so it would be real text with real English words in it, but there's words missing, and there's
Oh
misspelled
yeah, the
words.
misspelling, there's problems with spacing, 2 words get mashed into 1 word, or another word gets separated into 2.
Right.
What you do is you have, you know, like a word to int dictionary, and you kind of look at how many misses you're getting, and you can use that as a measurement of how accurate the OCR is.
And then below a certain threshold, you might say, throw it all out
Right.
and just do fresh OCR.
Yeah, so like, and I'll get into it a little later, from the Natural Language Toolkit, you can download the WorldNet Dictionary for English. I think it has about 200,000 entries in it, okay? And it's a hash table, so it's a very quick lookup. And you just test every word, okay? And if the word's not in there, it's going to come back not in there. And so if 50% of your words are scan errors, OCR errors, and are gibberish, you're going to have a 50% miss rate, and that could be your threshold to say, hey, this is bad. And you really wouldn't even have to do like the whole document or the whole page. I mean, one could speculate within the first 3-4 line, if I'm going to have bad OCR, it's probably going to be distributed evenly, right? Okay, so I only need to sample the beginning of the first page. You know, if I'm getting a high miss rate on the first handful of lines, I already know I'm going to get the same distribution in the rest of the document.
What tricks are available to help that? Does increasing the scan resolution or contrast?
Scan resolution is the primary one.
Okay.
The nice thing about Google's next version they're coming in, it's the one they've used in-house when they scanned all the world's books and stuff like that. Not the one they give free to everybody.
Right.
So their high premium one they're now giving free to everybody. That's 4.0. That's based on an LSTM, which is a neural network. So it too is learning spelling errors, skew errors, and things like that. So it can give better results on the more messier type of documents.
What does LSTM stand for?
Long short-term memory. It's a type of recurrent neural network that's popular in natural language processing.
And so everything you're doing here is in Python, which is not surprising.
Yeah, yeah.
Are there serious competitors?
You know, if people are getting into this area, I recommend that they stick with Python, because everybody who's came out with a framework does Python first. So if you're in Python, everything's available. If you're in any other language, it's catch up.
Gotcha.
Okay, so we just do here. So I'm going to do a length on my doc object. I've redefined the length operator. okay, to say how many pages are in it. 105. Okay, so let's go ahead and look at a page object. So what we're going to do here is, so I'm going to use the property pages on the doc thing. So that's basically going to give me a list of pages. Okay, if I print the length of that, sure enough, I get 105 back. I look at the last page. Of course, things are really 0 to n minus 1. It tells me, that's a page object. Okay, so let's take a little closer look at it. Okay. Okay, so I've taken that page, and I'm going to use the text property, and that's just going to show me the raw text on that page. So if we went to that document, and we went to the last page, we already know what's in there. It's the translated version of all the legal notices. Okay. But what's more interesting would be, of course, is starting to do an NLP analysis of it, which can be configured in different ways. The default configuration would do what's called stemming, stop word removal, and punctuation removal. So I get rid of all the punctuations. Okay, you lowercase everything, so capitalization doesn't really matter. You get rid of common words that don't add any meaning, the, and, a, and all that. That's your stop word removal. And then your word endings, like plurals or ing and all that, you chop them up. Okay, that's a common practice. And so this is just, if I go words, this is just showing me all the words that were on that page. Then you can start seeing things that look familiar. Health, plan, health plan. They show up a couple times. Health again, plan again. Oh, I wonder what this document's about. Okay, so we get past that. So that brings up an interesting property. Now that I can sort of do this type of analysis on the page, is one of the things they do in natural language processing and sort of dirt and cheap for classification is looking at the distribution of words. And they'll use the term corpuses or corpora and corpus, that in certain areas, like if it's all about medical, and within that all about medical plan, you tend to have a certain distribution of words. Okay? If they're legal documents, you're going to have a different distribution of words. So many times you can simply look at your distribution of words and already know what the overall document's about, or even make a fairly good guess what the page is about before you've even ever gotten into a neural network. Okay, the two most common ones are frequency distribution, and that's really just the number of occurrences of each word. And the other one is term frequency, and that's really the percentage of that word appears in that. In this case, we're doing it on a page. So let's run this. Okay. So on this page, we've got a frequency distribution. The word plan occurs 10 times, health 8 times, protection 4, benefit twice. We got things. So we can kind of tell on this page, if we look at just the top handful, what it's probably about. It's probably something to do with health and a plan and a benefit. Okay. If we look at the term frequency, oops, I went a little bit too far. Okay. In this case, it's a percentage, and that might be more meaningful. I mean, the word plan almost appears 10% of the time on that page. So that's a pretty significant word. And the word health appears almost 8% of the time. So you can now see why it's useful to do stop word removal. If I left in thes, a's, and ands, they would be up here, and that would just add noise. So what you're looking for are the words that are meaningful, not the syntactical filter. So let's go back up to the document. So that was the frequency distribution on that page. But if we go back to the document object and ask for the frequency distribution, I'll do it across, aggregate across all the pages. And here it's really obvious what the document's about. If you look at the first just 10, top 10, you're seeing service, provider, benefit, cover, health, care, medical, network, coverage. You know, it kind of gives it away. And certainly if you look at the top 25 on any type of document, you can pretty much accurately classify what the overall document's going to be about.
And what is the integer represent there?
The what?
The integer, 627.
Oh, the number of times that word occurred. Remember, this is what's stemming, so, you know, provide might have been providing, provider, provide, provides. They all been collapsed to the word provide. So stemming is the root word, if you're not familiar with that. It's another common thing we do in NLP. Okay, all that stuff was actually stored. Let's see, let me, I don't see it there for some reason. Okay, maybe I didn't run it. Okay. All right. Okay, so if you know Python, if I set that doc object to none, I just basically blew away that object off the heap. It's no longer in my memory. It's gone. Okay. I really don't want to say, if I want to retrieve and do something again, I really wouldn't want to do that whole process again, splitting all those pages, OCRing them, pulling out the text, building some tactical nets, all that stuff you save. So you can simply recall, let me get it higher on the screen. Okay, so here I'm going to create an empty document object, and then I'm going to load into that document object something that's been stored before. So here's the document I want to recreate, and here's the location of the components that I stored. So all that time, it's instant. That whole representation is now back in memory. So let's have a look. Okay, sure enough, when I print the number of pages, it tells me there's 105 pages. I know it's kind of low on the screen, so I'll make sure to get higher up. I go to the last page, I print the text. Shows me the text of the last page there. Frequency distribution. There's my frequency distribution. Okay, so it's kind of nice of being able to store it and then retrieve very quickly. And then again, to show you how asynchronous is done, so I got another little PDF here. It's a single-page PDF. It's the kind that people find very annoying in this type of work because it's a table. So let me see. Oh boy, where did I put it? I might have accidentally removed it. I might have accidentally deleted the file I was using it. Yeah, I did. Oops. Let me go back here. I still got it. There it is. Restore. We all got to do one boo-boo, right? When the first time we give a presentation and deleted a document. Where does it expect it to be? I went into, it should be, I think it's expecting it to be right here. There's crash. Oh, never mind. Named wrong. Okay, try it again. There we go. All right, and you can see my event handler just prints this statement. So I told this to do it in the background, and when you're done processing this document, call that event handler, and that's why that's printed on the screen. So that's how you can handle asynchronous. So again, what you might do is think you look at your processor and your system, and maybe you decide I can handle 100 documents in parallel on my server. So you create a thread pool of 100 threads, and you just stack these documents off of each other. If they're coming in faster, you queue them up in some kind of list, like a stack or a queue actually, and pop from dequeue from your queue as threads come available in your thread pool, and you just fire them off in the background using this async method. Yeah, you could, just to show you the document, it's probably what you guys hate working with PDF documents. This is Oregon Department of Transportation. It's a single page on a much larger document about traffic, in this case fatalities and accidents. And you can see how difficult it would be for a computer system to pull this information out. Usually what happens is people who use this type of information, any type of data analysis, some data entry person reads this stuff and types it in somewhere. Okay? And in that method, even with somebody who's very experienced at doing it, okay, if usually you only get about 70% accuracy, that means that for every item copied, a page, a table, or what, 30% of them will have at least one or more errors. Yeah, that's typically the expected rate, error rate.
For a page like that, would still be 99% accuracy by datum,
but there'll be 30% of them will have something entered wrong. Yeah. And I want to make sure people understand. It doesn't mean 30% will be all wrong. It will mean 30% of them will have at least one item wrong.
Understood.
Okay, so do that. So let's go look a little closer. But again, we could look at the frequency distribution of that document. We've never seen, the computer has never seen that document. It went through, does a frequency distribution, so maybe look at the top 15 words or whatever. I see serious, I see injury, I see fatal, crash, miles, death, highway. I think I kind of know what the document's about. This is going faster than I thought. So I'll do a little bit of the second session and let you guys ask questions. I thought this was going to take longer, but again, it's a dry run. I'm trying to learn how much information I can convey in an hour.
So when you call the
Frequency distribution.
Yeah, is that something that you're calling from one of the underlying libraries, or something that this library is actually, it's actually written in this library taking
in this
data?
case, it's written in this library. So, you know, underneath these document page objects, some of the stuff is going to some other open source component. Okay, and then other things, if they're really trivial, they're done inside the module itself. Okay, so if we were kind of drilling further down, you saw on that page there was a property called words. Okay, so it gave you the NLP tokenization of every word on there. And every word has its own object. Okay, so it should already be there. So I'm going to import the words class. And that might be, okay, I think I need to do this. Okay, good. There we go. So let's have a look at, so I could create an object called words and give it a bunch of words. Okay, in this case I'm telling it to remove stop words. And it's done two things. It's given me this list, and each list is actually like a dictionary entry. It's a key value pair. Okay, so it's telling me the word and the type of word. This tag 15 means that it is a male. Okay, and here consumer, it doesn't know what consumer is, so it's sort of the untagged or unidentified. Okay. There are other things it does. Okay. For de-identification, name entity recognition is really important. That's another common thing done in traditional NLP. That's being able to go through documents and recognize that's somebody's name, or that's an address, that's a telephone number, that's a social security number. Okay, so this system is trained to do that. So I just made up some sentence here. Word one, word two. Son of Jim Jones. Social security number, colon, something that looks like a social security number, and then some other word follows. So let's go ahead and process that. Okay, so without doing anything special, so it found all these words, right? Word one, word two, Jim. Notice Jim is tag 11. That means it knows that's a proper noun. Okay, where were we? Jones, it labeled as a proper noun. Okay, it recognized this is a social security number. Notice the dashes are all gone. It contracted together, gave it a tag 9. So it says that's a social security number, and of course it doesn't have any special meaning, word 1, 2, or 3. That's why there's 0. So let's de-identify that line. Okay, so in this case, we gave it this value, SSN equal false, and when it's processing that, it will strip out anything about a person's social security. So, there we go. Took out his name and the social security number, but left everything else in. So those are some of the basic capabilities, of the toolkit. And that's really all that I had prepared. So the rest is just talk freely.
No problem.
Yeah.
Well, that's pretty cool.
Yeah, yeah. Like I said, if you've been following, if you've taken courses like Udacity or the shorter ones at Udemy, or been following online blogs and that, you've probably seen the hundreds, if not even more, lines of code people are writing just to get to that first beginning point that I can start inputting data into a model. And that's what this framework is, idea is supposed to address.
What's even worse is I've seen a lot of courses like that will just hand you the pre-formatted data, and they won't even tell you how it's done.
Right.
And it's like, oh, welcome to NLP. We skipped the hard part for you.
Yeah.
Also use this neural network library. If you don't know how neural
Yeah,
networks
right,
work,
right, yeah.
you can get answers.
Yeah.
So it seems like, what's the timeline on OCR? Like, how long ago did that start being a thing?
I'm not sure what.
Like, when did you start being able to take a file as an image file and read characters out of it?
Well, they've been doing OCR at some level for quite a long time, since the early 2000s.
Okay.
It just gradually gotten better, and then it kind of plateaued out. It's as good as it was going to get with sort of the handwritten imaging algorithms.
Okay.
And then with the introduction of recurrent neural networks and the LSTM versions, people have found I can make OCR suddenly better. Okay, so that's why we're going to see a new version of Tesseract, and presumably others who build, like Lead Tools, who builds a commercial OCR system. We should see in the next couple of years a big leap in their performance capabilities, because they will now move from handwritten imaging algorithms to deep neural network learned algorithms.
I see. So if humans are at 70% accuracy on a full page, OCR is probably
Be typically in the 90s.
already.
Yeah, usually they make a pretty big leap coming right out of the gate.
It's good enough to scan your checks.
Yeah. Yeah, that's right. Yeah, right.
Right, well,
That's
scanning checks actually uses the old imaging technology. Same thing with the post office, scanning that zip code on your mail. That's how your mail gets routed. No human being is reading your mail. Okay, the machine is reading it, seeing the zip code and a few other things, and it routes it. It's not until it gets to that final sorting point is there a human being bundling it together for a particular carrier to put on his truck.
So you touched briefly on data binding.
Yeah.
But I'm curious the steps, obviously, after this, where you've cleaned up your data, you've got some analysis done, but now you need to structure it both perhaps to warehouse it for later,
Yeah.
like in a relational database or in a flat database.
Yeah.
How do you need to go about that?
Yeah, so certainly, the desire for the open source team is to create that. I kind of think of like this module somewhere near the front, that type of modules more closer to the back, but being able to couple that to, if you're extracting data, let's say that's your purpose, putting it into a relational database. Okay, if you're in the healthcare system, they want it into what's called an EHR. That's electronic health record. It's conceptually the same thing. There's a lot of needs in industry, not necessarily to understand the document or to make a chat bot or all those types of things, but really just I'm looking for certain information. I need to accurately pull it out, and that's going to be put into a structured system. Okay. And that's where you get into the data binding, and the ability of people to represent. Today, in a modern framework, people don't write tables anymore, and they don't write queries. They write an object description that is then bound to that. And so, this framework will try to find that concept and how to make it fit. So the idea here is, look at the modern design patterns that are being used in web development frameworks and find an equivalent representation. So then you're off the shelf. Your regular web developer can pick this up off the shelf. Doesn't have to learn something new.
So obviously the OCR recognizes lots of different languages.
Yeah.
Does that get piped into a dictionary that contains the different languages as well?
Well, right now the only dictionary pulled in is the English version of the WorldNet dictionary, but there are many to pick from, and as the framework picks up speed and contributors, takes contributors, we'll see more and more of that stuff.
And is it published?
Pardon?
Where's the framework published?
Yeah, it's actually in my GitHub account currently, so it's sort of the temporary. I actually just put it up there a week ago, so it's just uncloaking before it finds a final home. So actually, save you guys time. So since I'm acting as the executive director for it, I made a little card. It's got the GitHub account at the bottom. I forgot I had done that.
Thank you.
Get to everybody. You don't need that. Jump up. I can walk around. Oh, good. I got it now.
It's also listed on the meetup.
Yeah, I didn't know how this talk would go. I figured it was going to be really dry in other people's heads, but it seems like it was effective.
So you talk about your data binding and pulling out specific structures within the document.
Yeah, well, let's say you have to find a way to represent. I have documents coming in that say about a patient, and they're different documents from, say, different laboratories or different clinics, maybe from different hospitals. And I ask the question, I kind of bind the thing, let's say the patient's vitals, his blood pressure and temperature and all that. The system needs to be able, as this data comes through, spot those things and then bind those values to those items.
So does this give you any tools for making like a regular expression that you can then find matches with to create?
Regular expressions are the problem with regular expressions is you're going to hit that 30-70% problem.
Right. Or if you see a 9 and a 9,
yeah, right. And that's the traditional way of doing it. The way I see this going is it uses a combination of the common patterns, but then looks at the context, what's around them. You're generally better off with false negatives, I missed something, than you are with false positives. Okay, so the general approach is if you say something is you want high accuracy, that it really is that, you're willing to sacrifice missing a little bit to make sure that when you say something is something it really is.
How does the system deal with, it tags parts of speech in here.
Yeah.
I saw. How does it deal with like homonyms, for example? Is it
Like what?
Homonyms, like words that could either be a noun or a verb.
Oh,
That's really
well,
common.
you know, that's an ambiguity, and right now I know that it's just using I think it's the WordNet, I guess, dictionary, and unless you're trying to tell it how to resolve that ambiguity, it defaults to the noun version.
Is there a way to set up like a folder just to drop stuff in and already have this kind of running?
Yeah, there's a guy named Ernest that is working on a front-end module that sounds kind of what you just described. So yeah, this is sort of the middle nuts and bolts. Clearly you want to put other things in front of it that make it more user-friendly, and other things on the back of it that give you the ability to bind to stuff.
Where do those PDF resources, how are those generated?
Well, those are in the PDF file.
Right.
So whatever wrote the PDF inserted those directives in there.
So it's surprising that they would be pretty reliable.
Well, if the PDF is generated by Adobe Acrobat, I would expect them to be, right? But how many third-party PDF writing applications are out there? And they're not all perfect. They're not Adobe, are they?
Right.
So they're a little less than perfect. But because of that, Adobe has always said that they made Acrobat Reader really friendly to render third-party PDFs as well as they could, even if it violates their definition of the PDF language. That's why when you use Reader, it seems like you can read any PDF,
Yeah.
even though many of them weren't ever generated by Adobe Cloud.
So I've created a lot of PDFs, and is there like best kind of practice to use so that you don't have as many errors in designing PDFs?
I don't know. That's not my specialty. The only PDFs I ever create is usually when I'm in Word and I do, save as a PDF.
So, as you kind of laid out your prerequisites, you mentioned how much older GhostScript is.
Yeah.
And since you're extracting text directly from the PDF, and since we don't know without performing other qualifications on how good the text is, my question would be, why use GhostScript at all? Why not just throw away the text if it exists, or work from a rendering of it, or create your own rendering if it doesn't exist of something, and then just run image matching on it from the beginning? Why not just throw away text and start with an image?
Yeah, start with an image, then you got an OCR.
Right.
So that's a longer processing pipeline. And you may be introducing OCR errors that you wouldn't have if you took just the text.
So it might be a bad scan that has been edited by hand. I'm trying to think of a case where you'd have a bad scan or something that wouldn't run well on OCR but would have good text.
Yeah, I mean, I'm just thinking if your PDF has the text in it, then the most time-efficient route processing is to just pull that text out. Okay. If you instead rendered that page as an image and then ran that through OCR to get your text, you've got a much longer processing route, and you've added sort of a new variable that could introduce errors, and that's the OCR error. The errors that might occur during OCR.
Maybe like bigger text.
Yeah, like I'll give you a use case. So, for example, oftentimes you'll end up with, at least legal documents I've seen, you'll have real text that is high quality in the document, but the title page is the logo of the firm, for example.
Yeah.
And so if you look at the first, 50 kilobytes of the document, you're going to go, this is garbage, and then you're going to run OCR on the whole thing.
I think that's what this framework currently does. The algorithm, but that's a good point. I mean, I've certainly, posed that question. If you're basing whether it's a scanned document only on the first page, maybe there should be some randomness or some kind of gamma that gets you rechecking here and there.
Right.
Yeah,
Or count the number of pages and then use, in random and choose a random page to check what's on.
But like I said, it's just a beginning emerging algorithm, framework. So some places it uses the first obvious algorithm.
So pull requests then for you on that one.
Yeah.
Yeah, that's a good point. Because you would expect to have, here's a little image, and then there's some text. Here's another little image.
I mean, I've just pulled down a whole bunch of Lexis documents, and the 30% you gave, Lexis is more 50 or 60% error rate. Just about every document I pulled down from them has some kind of errors in it, and so it's a matter of, it sounds like having some upstream conditionality where you not only start with the words, but you have some threshold where you say, okay, I need to get at least 90% recognition of solid English words. Otherwise,
I gotta go this
throw it all
route.
out and revert to image magic and just do it.
Well, I'm gonna shut down, guys. My parking meter is to about 2 o'clock. So.
Yes, and the work calls. Well, thank you very much.
Okay, well, thank you, everybody. Especially for an ad hoc presentation that has no colorful pictures.
That was all text.
Yeah, what's with that? Everybody normally expects very colorful PowerPoint slides from you. All right. Well, I'm gonna see. Yes, I got everything. I'm gonna dart to my car because actually my meter was 159. Right.
Yeah, thanks for coming.
Pretty amazing difference in taste.
I like cold pizza. Like refrigerated pizza the next morning. It's my favorite.
I like it too, but when it's hot, that's my favorite. So, what do you got going this weekend?
I think I'm floating the river in Salem tomorrow with friends. And I might go hike Crater Lake on Sunday. Because I've never gone.
Is that like a 3-hour drive?
Yeah. Depending on where on the lake you go. It's about 3 hours from where I live.
You know, I've never been there. I've flown over it many times and seen it.
Uh-huh.
I've just never gone there. So it's on my list.
Yeah. That and Painted Hills. I'm like, I've lived in Oregon my whole life and I've never seen either of these like touristy cool places.
Oregon high cards.
Yeah. No wonders of Oregon.
Well, it's supposed to be really, it's supposed to be a warm weekend, so it should be good.
Yeah.
I floated in the river in Troutdale, but I've never. It's gonna be weird. It was in better shape back then too.
while it is leaking. It's leaking. I don't really box, so I don't know.
Where's it leaking out of?
I don't know. That's what I can't figure out. You're welcome to see if you can figure it out.
I worked on the Nespresso machine, that other machine that we have there. I designed one. Yeah.
Well, maybe you're smart enough to figure out what's going on.
You're making everything smell nice. These things, have you told them that you're just gonna throw them away?
Kicker's been on top of it. I know she's told them most of the time.
That's ridiculous. I'll call them. Say, hey, we're gonna dump these things and they don't dump it together.
I was gonna call them, I forgot to give them a call.
Yeah, because if you did.
I did the first time and they never came. I forgot to do it the second time.